Okay, so this is Monday. We're going to work on chapter 3. When people have trouble with this course, a lot of times it has to do with fractions. And it also has to do especially about like adding fractions and subtracting fractions. What I wanted to do is tell you something that I've never seen in a book, but it seems so critical that I want you to hear it. If you're going to add or subtract, okay, if you need to add or subtract, you must have like things. So this statement pans out in all kinds of ways. And with fractions, it ends up being, in order to add these two, we have to have the same denominator. And so, like I said, you never see this. To multiply or divide, you can multiply or divide anything by anything. But adding and subtracting is different. It requires like things. And in this case, this is in thirds and this is in fourths. And so what we're going to learn to do is turn this into a common denominator. Now we have lots of the skills. So you may know, I'm going to just do this one because the numbers aren't too bad. You always going to, when you pick a common denominator, which is going to go here and here, it's at least as big as the biggest one. And so you may be able to tell, I'm hoping you can tell, and I'll show you in a minute how to tell, that the common denominator needs to be 12. Now, in this particular case, it was done by multiplying the two, but that doesn't always work. But it does work in this case. And so literally, in the first section of chapter 3, they want you to find the lowest common multiple or least common denominator. The two numerically are the same. Now, the common denominator, the lowest common denominator is 12. The least common multiple, they would say, of 3 and 4, it would also be 12. But why do we care about it? It's because we need to add and subtract. And so we're going to eventually take this 1/3 and turn it into 12ths. So I'm going to finish this one problem and then start from where we need to start. We've done this before. We have this skill already. 3 into 12. Well, you say to yourself, 3 times what?
4.
And the what is 4, exactly. And once you put a 4 here, you have to put a 4 here. So we're actually multiplying by 1. So now it's 1 times 4 is 4. So the bottom line is 1/3 is the same as 4/12. This one here, 1/4, 4 times what makes 12?
3.
3, exactly. So 4 times 3 is 12, 1 times 3 is 3. Now we have what is required for this chapter, which is a common denominator. And I'm saying this, to add or subtract, you must have like things. In this chapter, it means common denominator. And so now what you do is you add the 4 and the 3, makes 7, and you copy the common denominator. Sometimes you have to reduce this. This one doesn't have to. Okay? So that's what I want to know. The reason that we're asking this question is so that we can actually add or subtract when the denominators don't match. So the first thing, so this is 3.1, and they're asking you find the lowest common multiple of certain numbers. Now, remember, it's the same as the least common denominator. And so if they have a number like this, 4 and 8, it's as if you had a problem like this, where you're adding 1/4 and 1/8, something like that, and they're looking for the common denominator. Well, what would it be? Well, the first thing you try is the biggest one, the bigger one, whatever it is it good enough for both? In other words, could you turn these both into 8s? And the answer is yes. You could, couldn't you?
Yes.
And so the lowest, least common multiple is actually 8. So the first thing you actually try is you look at your numbers and you look at the biggest one. And you say to yourself, well, would that work? And the answer is yes. Now, I want to do a slightly different one.
When you say look at the biggest number, can it be the numerator we're looking at, or does it have to be the denominator? That
We only care about the denominators.
okay.
So let's say I have 4 and 6, and the question is least common multiple. Now, multiples look like this, and so multiple of 4. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16, and you could just keep going, right? Those are the multiples of 4. Now I want to do 6. The multiples of 6 are 6. 6 times 2 is 12. 6 times 3 is 18. And I'm going to stop because I want the least, the lowest.
Well,
The first time we have a match. And this process of least common multiple sometimes will get you there pretty quickly. And so if we took the larger number and did multiples, and so although I did it for both, I wanted you to see that this was the first time they match. They may match later on as well, but this is the first time, the lowest number where they match. If you start with the larger one, you get there quicker. And so I prefer to go with the larger one. So let me do least common multiple of 30 and 20. Okay. So the larger one is 30. So this is what the problem would look like. And if it was actually an addition problem, this is what it would look like. What would be the common denominator?
60.
And that might help you see the answer. Doing it as a multiple, the multiples of 30, or 30 times 1 is 30, 30 times 2 is 60. And before I go any further, the 20 would work with 60, wouldn't it?
Yep.
And so I'm seeing 60. And so that I'm showing you a couple of different ways to see it, but 60 is definitely, so this is multiples. And so 20 is 20 times 1, 20 times 2, 20 times 3. There's your first match. The lowest common, the match multiple. Okay. So when I started with the larger one, I get there quicker. So let me do a different one. 30. Let's see if I want to do that one yet. 30 and 42. Now, as the numbers get larger, it gets harder to see what the answer might be. I suspect it's going to be a fairly large answer. Now, when the numbers are small or smallish, then you may be able to just, in some cases, guess, and other ways do multiples or something like that. But as the numbers get larger, it becomes more of a problem. And I wanna skip this for now, but I'm gonna come back to it. 12 and 15. I wanna demonstrate this with smaller numbers. Least common multiple or lowest common denominator.
Wouldn't it be 60? Because they both go in there 60?
Exactly. But now, did everybody see it was 60? So one way to, I'm gonna do it with multiples. I'm gonna use the bigger number 15. 15 times 1, 15 times 2, 15 times 3, and 15 times 4. This is it. And then I'm gonna do the multiples of 12. 12 times 2 is 24. I've got another way, so don't panic. 12 times 3 is 36. 12 times 4 is 48. And 12 times 5 is 60. That's the answer, the lowest common multiple. Now, even with these two numbers, it's starting to get messy. And so here's, this way is for sure to get you the perfect answer. It's the prime factors. I'm gonna prime factor 12. And if you remember, it's even, so I can divide it by 2. 2 into 12 is 6.
6,
And 2 into 6 is,
3,
that one's done. Let's do 15. Oh, 15 was not bad. No, no 2, but 3 and
5.
the answer lies with the primes. So the first one, the 12, was a 2, and a 3. The 15 was a 3 and a 5. Okay? The lowest common multiple or least common denominator. You look at these numbers and you have to make sure that all of these numbers are covered. So for instance, in the 12, I need a pair of 2s, don't I?
Yes.
With the 3s, I only have 1 here and 1 here. So I only need 1. I don't need 2, I just need 1. And finally, there's a 5 involved here. And so I definitely need a 5. Now, we'll practice this little trick, but this is when it starts to get tough. This is the answer. I have, as far as 2s are concerned, I need 2 of them. As far as 3s are concerned, I only need 1. 1 for here, 1 for here, I only need 1. And as far as 5s are concerned, I only need 1. This
How
is
come you only need 1 3 when there's 2?
because each number only has 1. So you have to just consider each number. Otherwise, you just be
Okay, I
multiplying the
got you.
2 numbers together.
So if the bottom 15, say it was like 10, and you had 2 2s, will I still only put 1 2 at the bottom?
You would need the most that, so for instance, if this one had 2 and this one only had 1, you would just need 2. You take the most
Okay.
because 2 would be big enough for 1 and it would be big enough for 2.
Okay.
But I want you to see that this is 60. Remember how we did commutative and we would switch the order and we would did associative property? Look at this, 2 times 5 is 10, right?
Mhm.
2 times 3 is 6. 10 times 6 is 60. Now you can do this the hard way. 2 times 2 is 4. 4 times 3 is 12. 12 times 5 is 60. But because I've done this 12 million ways, I see the 2 and the 5 would be a perfect thing to use, which is 10. And 2 times 3 is 6. I can do it in my head and not make a mistake. So I just wanted you to see that. That's the commutative and the associative property being used to our advantage. This prime factoring is one way that you can get a perfect answer every time. Now, do you have to do it every single time? I don't think so. because sometimes it's not that hard. Let me see if I can find some others. 42 and 70. Okay. The numbers are bigger. And so I don't think it's obvious. It's not obvious to me. And so what I'm going to do is show you this prime factoring approach. I'm going to go 42. It's even, so I use 2. 2 into 42 is 21. Now I have to use 3, and 3 into 21 is 7. That one's done, because this is prime. Now I'm going to do 70. 2, because it's even. 2 into 70 is 35. The next number prime number that goes into this is 5. 5 into 35 is 7. So what I want to do is, here's what 42 looks like as prime numbers: a 2, a 3, and a 7. You see it? Here's 70. That's what that looks like: a 2, a 5, and a 7. Okay, so now the question is the least common multiple, which is also going to be your lowest common denominator if we need it. We take the most 2's in any line. This one has 1, this one has 1. How many do I need?
1.
1.
1 will do it.
Mhm.
Take them in order. 3.
3.
I need a 3, even though I only have it in one place. I need the 3. 5.
1.
1. I need 1,
7.
5. And now here's another case. I have a 7 here, one of them, and a 7 here, one of them. How many 7s do I need?
1.
1.
That is the perfect answer. That's the lowest common denominator, and it's the least common multiple. And we are absolutely 100% sure that it's perfect. I'm going to play this game again because I want you to see I'm lazy, but I'm lazy because I know what I can get away with. Do you hear me?
Yes.
The 2 times 5 is 10. And the 3 times 7 is 21. The lowest common denominator is 210.
Oh,
You see, nobody in their right mind would have guessed that. Maybe they would, maybe they wouldn't, but mostly they wouldn't.
not guessing it. You won't
Not
guess
guessing it. This is where we're in the big league. We have to have something that will work all of the time. Now, can somebody use this prime factor method all of the time? If they want to, it will always work. But there's many times where it really, you can get it a lot sooner by just doing something. So this is the next section. So this is, I want to do, now they're asking for the least common denominator, which we already know is the same darn thing. So what if you had 1/3 and 1/5? They're not asking you to add them, but I always write them vertically just so that I can, this is how I'm going to do the adding when we eventually do it. Do you need to make a fuss about this? What is the answer?
15.
It is 15. And part of the reason was they were both prime, so therefore you're stuck multiplying the 2.
Mhm.
It would have been 15. And when there's no big deal about it, and hopefully you've done some of this successfully so that that looks right to you. So the answer you would turn in is just 15. Let me try this one.
Professor, can I ask a question really quick?
Go for
I
it.
just, because I'm about to write it down. So if both of the denominators are prime numbers, we can skip the steps and just multiply them by each other, and that would give us the LCD.
Absolutely. 1
Thank
over
you.
5 and 1 over 7, 35, no questions.
I was wondering why it worked with some problems and not with others, but that answered my question. Thank you.
And see, whereas if one of them was prime, but the other one was not,
Mhm.
no. No, then at that point in time, I would look at the larger one. So if they're both
Okay.
prime, we're done, 35. If they're not both prime, this is prime, but this isn't, so you don't have what you had over here. I would go with the larger one, which is 15. If 15 is good enough for both of these, then you're done.
Okay, great. Thank you so much.
Yeah. Now,
Thank you for asking that, Lisa. That's a good question.
that is a good question, yeah. And so now, sometimes it's obvious, is a 12 and a 16. Occasionally somebody can figure it out. But is anybody coming up with it, or should I just?
I think it's 60. I think it's 60.
I think it's not 60, because I don't think 16 times something is 60. 15 was. This is similar to the other one, but different. Okay, so here's what I'm going to do. I'm going to take the number 16 and the number 12. The
Mhm.
number 12, we did it a second ago, so I'm just going to repeat it. 2 into 12 is 6. 2 into 6 is 3. That one's done. 16 is a string of 2s. And I mean, they go on for a long time. 2 into 16 is 8. 2 into 8 is 4. Right? 2 into 4 is 2. So when you have 16, it's 2, 2, 2, and 2. When you have 12, you have a 2, and a 3. How many 2s do I need for my lowest common multiple or least common denominator?
2.
I have to take the one that has the most. So I have 4 here, and I have 2 here. How many do I need?
We need 2 2s.
Nope, it's not 2 2s. That won't cover it. To this
3.
one, I need
2, 2, 2, 3.
I need 4 of them. I
Mm.
need the most 2s in either line. This is the winner, and so I take 4 of them. Now, as far as 3s are concerned, I only have 1 down here, but I have to take it.
Oh,
Okay, so the most, and so another way that you might have done was 16, do it with exponents, 2 to the 4th, and 12 was 2 squared times 3. It's very clear that this one has the most. Right? And so this one had, so I need, this is 16, because we already just had it right up here, right? Times 3. 16 times 3. Did somebody guess? No, they guessed 60. It's 48.
I missed one.
It's 48. Do you see how they're not that? So once, see, this is what's going to happen. And this is the next section. Once we figure out what's the lowest common denominator, which was also the least common multiple, we then say to ourselves, and I did this before, 16 times what is 48? It's actually 3. 16 times 3, 18, carry a 1, 3 and 1 is 4. And then I have to put a 3 here. 16 times 3 is 48, 9 times 3 is 27. This might be easier. 12 times what is 48?
4.
4. 4. So 7, notice I put the dot there so I don't forget to multiply. 7 times 4 is 28. Once I have that common denominator, I'm good to go. This is where it gets easy. The hard part is getting it to this point. So 27 and 28, 27, 28. This would be 15, carry a 1. I'm getting 50,
45. 55.
yeah, over 48. Now, if they say they want a mixed number, then you give it to them. If they don't, then remember, there's times when you could actually turn that answer in. But if you somehow had to give them a mixed number, 48 into 55 goes once. And I'm going to borrow here and make that 15 take away 8 is 7. So the other answer is 1 and 7 over 48. This may reduce, but it doesn't in this particular problem, but this could reduce, it's possible. And so you look at it so that when you turn your answer in, it's considered simplified. Okay. What do you think? So we, now back to this one, the 16 and the 12. So those were the two numbers that you had to get the lowest common denominator or least common multiple. You could have done multiples. It just depends. 16 times 1 is 16. 16 times 2 is 32. 16 times 3 is 48. I can do it on the side, but that's what it's going to be. And then 12 times 1, 12 times 2, 12 times 3, 12 times 4. That's multiples. And just if the problem is not too big, then multiples might be the simplest way to do it. Once it gets out of control, your best bet is prime numbers. Because then you're assured that it's going to be right. And then, you know, you don't get tangled up. And this may, even this problem may just be too annoying for some. Okay. All right. So now they're going to go into adding and subtracting fractions. Let's try a subtract. 3/5 minus 1/6. The minute you see that problem, the first thing you look at are the denominators. Are they the same?
No.
No.
They were. If they were the same, we'd be done, just about, but they're not the same. And so what we need to do is get a common denominator. What do you think?
Yes.
30.
It is 30. This one's prime, this one isn't. But let me look at what the prime numbers are. The 5 is just 5. And the 6 is just 2 times 3. Right? This is where you start to see what's going on. You're not guessing anymore, you're seeing. And so the most 2s would be 1, the most 3s would be 1, the most 5s would be 1. In the end, in this particular problem, we ended up taking the whole thing, which is 30.
30.
But the prime numbers told us we didn't have any matches. We needed a 2, we needed a 3, we needed the 5. That's 30. And maybe that was obvious because you've done enough of these that 30 looks right to you. So 5 times what is 30?
6.
6. Now, there's all kinds of ways people learn to do this. For me, this works the best, writing my numbers vertically so that I can expand them this way. If you have another way that works perfectly for you, stick with it. If you don't, I think this is the best way to do it, because I'm thinking not only about this course, but the course that follows it. This will work the best. So 3 times 6 is 18. Mhm. Now I do this one. 6 times what is 30?
5.
The 5, that's a 5. So 1 times 5 is 5. Now, what kind of errors do people make? They forget it's subtraction.
Uh, Yeah.
Did all the hard work and then they forgot it was subtraction. So pay attention. 18 take away 5,
13.
13, and you over the common 30. So does that reduce? Would you bet your life on it? Does it reduce?
No.
It's a no. The one clue is 13 is prime, and there's no factors of 13 and 30. And so that's good to go, isn't it?
Yep.
Okay. Why are we doing this? Because to add or subtract, you must have like things. And in our case, that means common denominator.
Okay, what happens if you're adding and the bottom numbers are prime, the denominators are prime, you multiply. What if you're subtracting and the numbers are prime?
Same thing.
You still multiply?
Yes,
Okay,
because add and subtract are the same. They're working with the same rules. You just add the numbers or you subtract the numbers. Let's see. Oh, well, every once in a while, life is good. Why did I say that?
Because they had a common denominator.
They have a common denominator. So you say, thank you, thank you, thank you. So, right? 7 take away 4 is 3
3.
over 9. What this problem required was this. If you turn this answer in, they're going to say, wait a minute, can't you do better? And the answer is yes, of course, because there's 3. And so either you divide both of them by 3, or
1 over.
one way or the other, you're realizing there's a common 3. And so the answer actually in the end is 1/3. So that's the answer they want. They always want the simplest answer. It's equivalent. Okay, so that part was good. Now the question is, what would happen? Oh, well. Oh, here we go. 5 over 12 plus 3 over 8. Adding and subtracting is the same. Just be sure and add at the very end so that you don't mess it up at the very last thing. We need a common denominator.
24.
See it.
Yeah.
24. You see,
Mhm.
the lar- so I'm not trying to do the hardest way every time. The numbers are relatively small. So I'm thinking 12. 12 times 1 is 12. 12 times 2 is 24. 8 will go into 24. 24 is the winner. Is that good enough for you?
Oh, yeah.
Yeah, I don't like a fuss if we don't need it.
Me neither. I don't like the first one we need it.
We don't need a fuss. 12 times 2 is 24. 5 times 2 is 10. That one's good. And I like this structure because then if you make a mistake, you can see it. It's right in your face. 8 times 3 is 24. So it's 3 over 3. 3 times 3 is 9. This is ready to roll. The 10 and the 9. 19 over 24. Does this reduce?
No.
No.
No. 19's prime and 24, I don't know what it is, but there's no 19 factors in there.
How come You couldn't have been my teacher 6 years ago. 'Cause
Oh, but I've been at this a while. Okay, let's see what else. Oh, here. I want to do this one with 3 numbers all at once. 1/5 plus 1/6 plus 1/7. Oh my. Oh my. The common denominator is relatively large. The 2 of these are prime. The 5 and the 7, right? This 6 is made up of 2 times 3, which there's no repeats here or here. In the end, you have to take it everything. Because if you prime factored 5, you'd get 5. If you prime factored 6, you'd get 2 times 3. And if you prime factored 7,
7.
you'd end up taking everything, wouldn't you? You'd need a 2, a 3, a 5, and a 7. Remember my cute little method? 2 times 3 times 5 times 7. We did this earlier. Do you
oh wow.
remember? See how lazy I am?
Wait, do that one more time. Do a different problem, like the same. I need to see that one more time.
Okay, let me just let this roll. So
Okay.
what's the common denominator?
30.
Wait a minute, it's all of this. So 2 times 5 is 10. 3 times 7.
21.
Remember how we did this earlier?
Oh, 210.
2,
210.
10. Like it or
No.
2, 10. See what I'm saying? It doesn't always happen that the number is so big, but we can survive this,
Oh,
right? 5 times what is 210? Well, now I want to show you something else.
And 20.
2, 3, 5, and 7 is 210. Everybody, right? 2, 3, 5, and 7 made up the 210. If you need 5 times something to get 210,
5 times 40.
out, you need the rest of these factors. You need a 2, a 3, and a 7. 6 times 7 is 42. When you had 6 and you wanted to turn it into 210, here's what 6 looks like. What do you still need? You need 5 times 7, which is 35. Now, if you don't believe me, 35 times 6. Can you see it?
Yep.
And when you had 7, here's the 7. So you already have 7. What you need are the rest of the factors. A 2 and a 3 and a 5. This is 6 and 5 is 30.
30. Okay.
The prime factors, when they stop teaching prime factors, and it depends on your age and when you were in school. When they stopped teaching it, they did a terrible thing.
Yep.
Because this is how to see into the problem. And do you always need to do this? No, I could do this on a calculator, to be honest. But to understand what's going on, my goodness. And so this one here, maybe 5 divides into 210. You could do it out the long way. But when I take the 5 out, it's 6 times 7 is 42. It saves me a step, doesn't it?
Because the 5 is only underneath that 1/5, right?
That's right. And so 5 is one of the numbers that make up 210. So when 5 is out, What's left is 2 and 3 is 6 times 7 is 42.
Oh, son of a gun. Okay. All right.
42. This is 35, and this is 30. And then what you have to do then is add those three numbers and put it over 210.
Okay.
We don't have to always do the world's worst, but honestly, we could if we had to. Okay? I don't want to scare you with this problem because it's like, I wanted to show you the advantage of the prime numbers. 9/40, subtract 1/30. You could do multiples, you could do primes. I think we could probably survive with multiples.
You at 120?
I like it, don't you?
I do.
You like 120?
I like 120.
If you ever make a mistake, you would, and it was a subtraction problem, you would have to reduce it at the end because you picked a number too high. That's why they want the lowest common denominator, the lowest one, so that the numbers are as small as possible. This is not that small, but it's there. 40 times what number makes 120?
3.
Just 3. So this is 3 and this is 3. 9 times 3 is 27. Like it or not. 30 times what? Makes
4.
4. And 1 times 4 is 4. And do not forget to subtract.
Okay.
20
23.
over
23.
120. Do you recognize this as prime?
Yes.
It is a
Mhm.
prime number. And 120, no, there's no, that's done. What do you think?
I like it.
All right, well, maybe not everybody will like it, but there you go. I want to do mixed numbers. Now, let's see, it's actually not that much worse, except for one situation. Let's do adding. So it's a mixed number, and so 3 and 4 is 7. That's no problem, right? The problem is here with the fractions. And so let's just focus there, because the problem is not, I can add 3 and 4. But the 3 and the 5 in the fractions, I need a common denominator. Now they made it kind of nice. It's not so hard. Can you tell what 3 and 5 would be?
5.
15?
It's 15.
15.
Remember, it's always as big as the biggest one and probably bigger. It's always as big as the larger denominator. And so this would be 3. And we're going to turn it into 15. This is 4, and we're going to turn it into 15s. Right?
Mm-hmm.
Again, here it is, a 3 that wants to be, it's a wannabe. 3 wants to be 15. What do I have to bring in? What number?
5.
5.
By 5.
And notice I always leave a little space so that I can write it in. So 3 times 5 is 15, 2 times 5 is 10. The 1/5 is where the problem is. 5 times what makes
3.
15?
3.
3.
1 times 3 is 3. I am ready to roll. So 10 and 3 make 13 out of 15. And don't forget this. This is the
7.
easy part. That's why I copied it over, but 3, 7.
Got it.
13 over 15. So the 3 and the 4 didn't really matter except for remembering to do it. The whole job was to get those crazy fractions.
So if I see an improper fraction like that, or another improper mixed number like that, like just kind of don't ignore but forget about the big numbers and just take care of the fraction itself.
I'm not sure what you're thinking about, but I know where I'm going next, so let's. Oh, I did. Oh, yeah. Once in a while, when we get a final answer, there's an improper fraction involved. And so maybe that's what you're thinking about. If not,
No, my question was like, we have a problem just like this one you just wrote. So in my head right now,
yeah,
I'm not even looking at the 5 and 9. I'm just looking at the 3 over 4 and 5 over 6. And then later on when I solve
thinking
it,
about making them improper.
yeah. And like when I solve it, then I'll go and add the 5 plus the 9.
Uh-huh.
Uh,
You know, it's sometimes hard to tell what's a good plan. When the numbers are smallish, like the 5 and the 9 are not so big, that you might be able to survive that. But I don't really recommend it because really this 5 and 9 are like, who cares? I mean, it's 14, but who cares? I'm interested in this part because that's where the action is. And then I'll try not to forget to put it in my answer.
okay.
But I know I know what you're thinking about. It has to do with subtract. So let's finish this. Can anybody see the common?
12.
I don't, yeah, 12 is right. So I'm going to go 12, and this would be 9, and this will be 12. And so 4 to make it a 12 needs a 3. I like it like this because I can see what I've done. It's not like I have to start over. I can just see it. And so 3 times 3 is 9. And then this is 6, wants to be 12, so I need a 2. This is 10. The issue here is when I add this 9 and 10, I get 19 over 12.
Mm.
And when I add this, I get 14. Now, this by itself, 19 over 12 would have been a fine answer. They would have accepted it. But this, with the 14 like this, it's like, let's say this is money. Do you have $14 in change, or do you have more than $14?
Yeah, more than 14.
You have more than 14. So this is, all of the answer is there. It's just not the simplest version of the correct answer. And so let's say what it really is. It's 15 and change.
Yeah,
15 and a fraction. So what we want to do, literally the way you would say it is what you need to do. This is 14 and 19 over 20. So 19 over 12 rather. So this is 1 and 7/12. This is 14 and 1 over 7/12. So the answer they're looking for would be 15 and 7/12. You see that they're going to argue with you if you give them this. This is like a fraction that didn't get reduced. It's like it could be better. Do you want millions and millions, or do you want a nice little answer, like 2/3? You want the simplest thing you could give them. This is it. This is also kind of, it's like 14 and change. No, it's 15 and change. That's the more accurate answer. Is that
How did
okay?
that 7 become a 9? I mean, that 19 become a 7. I'm confused.
Well, maybe I did it wrong. 12 into 19 goes once. I'm just working this.
Mhm.
How many's left over?
7.
Oh, okay.
Right? So it's 1. You might have done it in your head too. 12 into 19 is 1, 7 left over, 7 12s.
Got you.
Got it, good, okay, yeah, we don't want to leave the things like that. Now, the issue, and maybe this is what you're thinking about, because you know, everybody's kind of remembering things from before. The issue sometimes has to do with subtraction. Subtraction kind of could have a problem. And when I go to, I had a common denominator, that's good.
Mhm.
But I had another problem. I'm taking 3 and I want to take it from 1. Oh, it's a borrow problem.
He borrowed from the impropers.
Yeah,
From 8.
somebody showed me something cute, and you may like this. And I want to rewrite the problem so I have a little more space. 8 1/4 subtract 3 3/4. Okay. Somebody taught me this. They learned to do it this way. You don't have enough, do you?
No.
Mhm.
So you borrow 1 from this, fine. But the one you borrow, they put here.
Oh,
Now this is now 7, and this is now 1 1/4, which is 7. Remember how he would do this? This
Mhm.
is 4 1 is 5/4 minus 3 3/4. To
Okay.
me, it's the neatest thing I've seen on this, because if people have trouble with this and they do the kind of things that we're talking about turning it into improper fractions. The truth is, we just needed to borrow 1. So the 8 became 7. But the 1 that we borrowed, we put here, 1 1/4 is 5/4. Now this is ready. 5 take away 3 is 2/4. 7 take away 3 is 4. And that's pretty good, but 2/4 needs to be 1/2. Is that right? Divide by 2, divide by 2. Did you like it?
Love it.
I think I had never seen that, but it beats all the other ways I've tried to teach. Let me, okay, so we might have another problem. 4 3/4 subtract 1 5/6. I suspect 2 problems. Okay, we've got mixed numbers. Okay. So I'm going to, first of all, get a common denominator. With a 4 and a 6, thank goodness that's not too hard. What is it going to be?
well,
12.
12. Okay, so this one, the 4 gets into 12, needs a 3. 3 times 3 is 9. Okay, the 6 wants to be 12. I could see what was going to happen here. 5 times 2 is 10. The unfortunate thing is a subtract.
oh,
Well, okay. I've got common denominators. That part's good. I'm going to have to borrow. I need to take the 4 and make it a 3. I'm going to put the 1 right over here. I'm going to move over. So this becomes 3. 12 times 1 is 12, 12 and 9. make what?
100 and,
New,
100 and,
we multiply here and we add
No.
here,
11, 21.
21. So it's 12 times 1 is 12 plus 9, remember?
oh, plus 9, I was multiplying.
Yeah, don't do that.
Okay.
And then it's minus 1 and 10, 12. You see how we borrowed? When we borrowed, we now have a number big enough.
Mhm.
So 21, take away 10 is 11 over 12. 3 take away 1 is 2. That one's done. So let's look at this. This is the worst of the lot because it requires borrowing. Not only do you have to get a common denominator, of course, it wasn't a big deal, it was a 12, big deal. But then when you went to look at it and you could see for sure that this was smaller than that, you had to borrow. And so this, the 4 went down to 3, the 1 came over here. We then made this a sweet little improper fraction. 12 times 1 is 12 plus 9, 21. And now it's good to go.
Can I see the last problem that had the borrowing?
So I think this was the original problem. So the 8 became a 7. The 1 went over here, so it's 1 1/4. We then made that an improper fraction, which is 4 plus 1 is 5/4.
I see. Okay.
There's other ways to do it. And honestly, probably everything I could show you could be done multiple ways. But I don't know. I'm gonna do one more like that. 13 1/6 minus 12 5/8, I think. The good news is when they force you into making borrowing and everything, they don't make the common denominator that hard. After a while, you say, I've seen that one before, a 6 and an 8.
24.
24 it is. Okay. 13. And it needs to be 24. This is 12. It needs to be 24. I can clearly see the 6 needs a 4 to bring it up to 24. 6 times 4, 24. 1 times 4 is 4. I just copied the 13 over. This 8 needs to be 24. It needs to be 3. So 5 times 3 is 15, and you can see what happened. It's the same as before. It requires borrowing. So the 13 to borrow would be 12. The one that we borrowed comes over here. Move this over just a little bit. So this becomes 12, and then we make that an improper fraction. 24 plus 4, how much?
28.
28 over 24. This is minus 12 and 15 over 24. This is now in good enough shape. 28 minus 15,
3.
13.
13.
13 over 24. And 12 take away 12 is 0. So you
Mhm.
just have the fraction answer. 13 over 24. What do you think?
Mhm.
Awesome.
All right. So what I want to do, I think that's probably I want to go, let's see, I want to see, some people sent me chats, let's see. Ooh. Yeah, people are talking about the prime numbers. Honestly, in my heart of hearts, I think somebody thought that prime numbers were just too hard for everybody. And when they took them away, they took away what you really, really needed. That's in my heart of hearts what I think. Whether it's true or not, who cares? But that's what I believe.
Would you say, in my head right now, I'm thinking a prime, if I see a prime number when I'm dealing with fractions, when reducing, a prime number is equivalent to a stop sign.
Yeah. Yeah, you know what I like to think of it? Can you see, guys see XYZ homework?
Yes.
I think of prime numbers as the building blocks
Okay.
of all the other numbers. So they're super important. We can't ignore them. Every number is either prime or made up of primes. That's the fact. And so they're important. Let's see. I want to go, so notice I wrote an assignment 3.1 and 3.2, I moved it to Monday. If for some reason, I think what I'm going to do is I'd like you to work on these first three sections. 3.4 we haven't talked about. Let me click on some of this. Let me do 3.1. Ah, well, now we should be in better shape to do this. Find the least common multiple of 3 and 12.
12.
12, the bigger number, if it's good enough, we're happy, use it. 3 and 4,
12.
12, good enough. Oh dear, some of these are so easy now. 1 and 5,
5.
oh, cute. 100 and 300.
300.
300. So if the bigger number is good enough, grab it. And so that's a rule.
So how can we answer we put only 300 or we can find the
300. 300.
okay. Okay.
Let me try. Find the
Okay,
least common, yeah, find the least common denominator. Now we're just looking at the fractions, but it's really the same job. A 3 and 4, your answer?
12.
Exactly. 6 and 8, we've done that before. Tell me if you remember it.
24.
28,
24.
24, yeah.
And I would probably go with multiples. 8 times 2 is 16, 8 times 3 is 24, 6 goes into 24. Good. Let's see if they get harder. Oh,
Yeah, they get harder.
okay. I've got the 15. I've got the 6. And I've got the 18, right? So those are the three numbers. They don't want me to add them. They just want me to get the common denominator, least common denominator. You know what I would do with this problem? I'd go to primes. It's quickest. It's a lot better than doing multiples. Let me just get this one done. 15, 3 times 5, right? 6, 2 times 3, 18. I don't know if you remember it. 2 and 18 is 9, 3 and 3. So that would be a 2, a 3 and a 3. So the least common denominator or lowest common multiple, it doesn't matter what they say. You take the most 2s in any line, you take the most 3s, you take the most 5s. How many 2s do I need?
1.
1 is the correct answer. How many 3s do I need?
1.
No. 2.
I need 2 because this has 1, This
Oh,
has one, this has two. I need to take the one with the most, so it's covered. So I need two of them. Fives, how many do I need?
one.
Right.
That's the answer. Now let's. Remember my shortcut?
Mhm.
I don't want to multiply,
Mhm.
blah, blah, blah. 10,
10 times 9.
10 times 9, answer.
19.
I think this was the quickest way to do these problems. Otherwise, I think you'd be spinning your wheels.
All right.
But it wasn't that bad. I mean, 15 was easy, 6 was easy, 18 wasn't that bad. The real problem was to stare at this. I need a single 2, but I need 2 3s. Because that's the one that has the most. And then I have a single 5, and then I put it together and I call it 90 for my answer. How do you like it?
So we put now 90 for
Yes,
the
that's
answer.
all they wanted. That's all they wanted. Let me see. The problem.
Mhm.
90. They liked it.
Okay.
So this is what I'm going to do with the calendar. I know our time is up. I'd like you to work on the first 3 sections.
Mhm.
I'm going to move 3.4 till Wednesday or something, and I'll eventually get these things straightened out. But I'd like you, 3.4 is just order of operation, but it's doing the same things we've done, but I haven't gone over it yet. But I do think you can work on these 3 sections because they're all tied. You know, get your common denominator. Add them or subtract them. Then it includes that mixed number, which could involve having to borrow. You might have to borrow sometimes, not always, but sometimes. How's that for a plan? Can you do it?
Yes.
Sounds great.
One at a time, then use a late pass, because I'm going to give you more if you need them. Just send me a message. But anyway, but yeah, but work
We
on
do
those
for,
things and you'll
for
feel,
Wednesday or Friday.
these 3, 3, 1, 3, 2, I'm going to put them on Wednesday. I'm going to be fooling with these assignments.
Okay.
Let's, actually, you probably could do them by tomorrow, couldn't you?
I can do it. Yeah.
Let me just move them to some of them to Tuesday. Yeah. Let me just move them to Tuesday for now. Okay. So I'll do that in a second once we get off air. So. But work on them. I'm going to set the deadline for Tuesday night, and then you can use a late pass if for